Is there a planet out there in space that resembles our Earth and even harbors life? Besides the search for the origins of space, the search for other life forms is the main goal of many astronomical research projects. For about 30 years, we have been able to detect planets outside the solar system, and among them are so far several dozen planets that have been classified as Earth-like. But is there really evidence of life there? And do planets possibly even exist in the universe, which are still more beautiful and more suitable for life than our homeland? The Earth Similarity Index. To make the search for life beyond our planet more focused, scientists have developed a scale called the Earth Similarity Index. This value measures a planet's similarity to Earth based on various parameters such as temperature, atmospheric pressure, and habitability. The scale ranges from 0.0 to 1, with 0.0 being non-Earth-like, and worlds with a value of 0.8 to 1, indicating that a planet is similar to Earth in many ways. The kings of Earth-like planets are super-inhabitable worlds. Such planets are roughly older, slightly larger, slightly warmer, and possibly wetter than Earth. In recent years, technological advances have allowed us to discover more and more exoplanets with striking similarities to Earth. Two of these worlds are TOI 700d and D. TOI 700d and D. The TOI 700 planetary system stands out among the crowd of about 500 known exoplanets. Within the system, there are as many as 4 planets that could be Earth-like. 2 of them lie safely within the star's habitable zone. The most promising are TOI 700e and TOI 700d. Both rocky and with similar masses to Earth, they could provide excellent conditions for life. T0Y700e has an orbital period of 28 days and is 95% the size of Earth, while T0Y700d has an orbital period of 37 days and is 105% the size of Earth. Orbital period in this case means that a year on TOI 700e is only 28 days, and for its neighbor TOI 700d, a year is only 37 days. Although the planets are so close to their star, they probably have a very mild climate. This is simply due to the luminosity of the star, TOI 700, which is much fainter than our Sun. If TOI 700e and D have atmospheres, they would still be much warmer than Earth's average temperature, however. The planets could be something like consistently tropically warm worlds. What seasons might look like on a world with such short annual cycles is left to our imagination. Do you have an idea? Then share it with us in the comments. Whether there really is life in the TOI system is currently still a big unknown. Both planets are about 1.5 billion years old, which is actually not enough by earthly standards to allow complex life to emerge. But we must not make the mistake of applying our earthly standards to the entire cosmos. We know too little about how biospheres can be constructed in other worlds. Even in our world, evolution still provides surprises. We are constantly discovering new forms of life that we never thought possible. Algae have appeared in boiling hot thermal pools. Crabs have been found under the kilometer-thick ice layers of Antarctica that only need to breathe once every few thousand years. And fungi have also appeared in Antarctica that feed on fuel residues and could one day clean our oceans. We must expect, with a strange world billions of kilometers away, rightly that life will surprise us there. Whereby we, of course, always hope to find life that resembles us. Who knows, perhaps we'll still find it in the TOI system, because scientists assume that beyond TOI 700d, still further clues exist. T Garden B, an exoplanet with the beautiful name T. Garden B is considered a true super-Earth. This planet, about 12.4 light-years away, orbits an M-type star every 4.9 days, making a year in this world even shorter than on the 2 TOI 700 planets. The T Garden star is one of the closest stars to us and is very observable. Although the red dwarf has 10 times less mass than our Sun and a temperature of only about 27 degrees Celsius, it can still supply its quite nearby planet, T Garden B, with enough heat to theoretically give rise to life there. Despite these differences on annual length and proximity to its star, T Garden is so far the king of Earth-like planets. in fact with an Earth-likeness value of 0.95. It is the planet that most resembles our home among the many thousands of exoplanets known to date. With a 60% probability, this exoplanet has a surface temperature between 0 degrees and 50 degrees Celsius. If it has an atmosphere, the surface temperature would probably average 28 degrees Celsius. In the neighborhood lies T-Garden C, another hot candidate for extraterrestrial life. T-Garden C is farther away from its star and still has an Earth-like value of 0.68. Only scientists have found that the probability of a mild and warm surface temperature here is only 3%. If the atmosphere of this world resembles that of Mars, the estimated temperature would be only -47 degrees Celsius. Researchers are not sure what the atmospheres of the two planets are like. Previous scientific methods for detecting and measuring exoplanets have not allowed for this research. This is where all hopes now lie. With the new James Webb Space Telescope, this new superstar among telescopes can, for the first time, scan the surroundings of exoplanets so intensively that even water vapor, and thus indications of an atmosphere, can be detected. However, the search for life on T-Garden B and C still has one small catch. Both planets are orbitally bound to their star. That means one side always points to the star, while the other side hardly gets any light. On one side is always daytime, and on the other, eternal night. This phenomenon is strikingly common on exoplanets, similar to our Earth, and scientists have already found that there is a thin rim on these planets that is best suited for the development of life. Can you imagine what life would look like on such a planet? Only a thin strip is covered by vegetation in light, and the rest is either too bright and warm or too dark and cold. In the end, this kind of habitat wouldn't be that much different from our world, with the climate zones becoming cold and inhospitable further and further north and south. The high sea and planets, new exo-worlds. What if life doesn't function only by Earth yardsticks, and we must extend our horizon massively? Just a few years ago, astronomers discovered a whole new class of exoplanets, known as Haitian planets. These planets are very different from Earth, but could very well support life. Icy and planets are ocean-covered planets with hydrogen-rich atmospheres that allow for a larger habitable zone. Compare it to Earth. These warm ocean planets can be up to 2.6 times larger than Earth and consistently have very high atmospheric pressure, reaching nearly to 100 degrees Celsius in places. Nevertheless, the abundance of water could support microbial life. Much like Earth oceans, the seas of these exotic planets could provide cooler areas in the deeper layers that allow for life. Icy and planets are far from being covered only by water, however. The surfaces of these planets have very different environments. There are consistently dark worlds, and those with bound orbits even icy. Worlds that receive little radiation from their stars fall into this category. The necessary heat comes from surface pressure, even though this would be about as high on the surface of such a planet as it is at the bottom of our oceans. Life exists in the deep-sea trenches here as well. This has been proven by expeditions to the Mariana Trench and other deep-sea habitats. Vertebrates cannot survive under these conditions, but microbes and mollusks, such as small crabs and octopi, cope very well. So far, we don't know if more complex terrestrial invertebrates can exist. Life could also exist in the higher layers of the atmosphere of these worlds. The dense, heavy envelopes of these planets are conducive to allowing microbes to thrive. Scientists believe that the discovery of this new category of planets will rapidly increase our chances of finding signs of life outside our solar system in the next decade. Icy world, K-18b. K-18b is one such icy world. Discovered 124 light-years away, the planet was discovered in 2015 by the Kepler telescope. The small space telescope was designed only to detect exoplanets in the far reaches of space. Kepler discovered K-18b in the constellation Leo. Initial measurements reveal that it's a type of mini-Neptune orbiting a red dwarf that is only quite faint. Researchers believe K-18b could support life because biomarkers, methyl chloride and dimethyl sulfide, have been found in the planet's environment. Life forms on this planet would likely be based on hydrogen-based biochemistry. This would mean that organisms there would have a fundamentally different structure than carbon-based life forms. They could look completely different and have a completely different structure than any life forms we know from Earth. There is even the possibility that we would not initially recognize hydrogen biochemistry-based life as living things at all. New insights thanks to James Webb. James Webb will be the first telescope ever capable of detecting all the biomarkers surrounding an exoplanet, and the telescope's reach goes a long way. It will take a while for the telescope to tackle all the Earth-like planets and eventually set out to find new exoplanets. Webb will start by looking at star systems and planets within a 35 to 150 light-year radius of Earth. After analyzing the atmospheres, researchers will be in a much better position to say whether life, as we define it, is possible there or not. In the future, the telescope's scarce observing time will be used primarily to search for planets around K-stars or orange-red dwarfs. Somewhat cooler and less luminous than Sun-like stars, K-stars have lifetimes of 20 to 70 billion years. Compared to Earth, life on a planet orbiting such a star would have more time to evolve, and our chance of finding life would increase. But what do you think? Do you really believe that it makes sense to search for worlds that are even more beautiful, better and bigger than the Earth? And what would such a perfect exoplanet look like to you?
Subscribe to my channel. Subscribe to my channel. Subscribe to my channel. Subscribe to